I hope you are quite well, happy, and your study is going very smoothly. Today, we are going to start here the Cannizzaro reactions. This is lecture number 22 of total aldehyde topic. And let's just start strengths. All the things we study here, detailed with the mechanism, with the questions. So please, you understand. If you want, once you understand, please like, share, and subscribe the channels. Let's just start here. I write here Cannizzaro reactions. See strengths. What type of compound will involve with the Cannizzaro reaction? See, those compound which do not have, first I write the condition. The condition is, what the condition is? First, those compounds which do not have alpha hydrogens. Alpha hydrogens will involve in the Cannizzaro reaction. Means what? See here. Formaldehyde, we have what contains alpha hydrogens. Similarly, one more compound here that also not involved with have alpha hydrogens, also involved in the Cannizzaro reaction. Similarly, here you can check that also involved in the Cannizzaro reaction. And C, CH3, 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 CHO also involved in the Cannizzaro reaction. Okay. So these compounds do not contain alpha hydrogen and will be involved with the Cannizzaro reaction. Okay. Now, see that. Second point is that strong base, we take here the strong base, means concentrated terms we'll take here, either the 50% NaOH or 50% KOH, or even you can take the 60% NaOH like that. Okay. So third is that Cannizzaro reactions undergo into the disproportion reactions. Undergo disproportionation reaction. So it will involve in the disproportion reaction. See here with one example, then we understand the mechanism. HC double bond OH plus HC double bond OH we have, that is the conc NOH we have taken here. So what will happen? That will form the CH3OH plus HCOONA. Students, you can observe here through this formaldehyde, we can get that methanol as well as sodium methanol. So one compound is a reduced form, and this is the oxidized form. That is the reason this is called disproportion reaction. So it is completely redox reactions. It is a completely a redox reactions. Okay. Now see here. Now my questions to all students. Can you tell me this compound will undergo into the Cannizzaro reaction or not? Here are benzene CHOOH, and I write here that is the second molecules is here, is Cl, CHO. Third I write here CH3, 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 C double bond O, CH3, CH3. So such type of compounds strengths will not involve in the Cannizzaro reaction. There are so many compounds, like you can see here PH means phenyl group, that also will not involve in the Cannizzaro reaction. Cl, CHO. So this compound will not undergo in the Cannizzaro reactions. Why? Once you understand the mechanism, you can get the answer. So let's start that mechanism why this compound will not involve in the Cannizzaro reactions, and those which do not have alpha hydrogen like this compound will involve in the Cannizzaro reactions. Let's understand the mechanism, then you can understand yourself here what will happen. So first is that rapid reversible addition. Rapid reversible addition of nucleophile OH minus, which is a nucleophile to the carbonyl group. Okay. So see here, H C double bond OH OH negative, that will attack here. It is reversible process students. So what will happen? HOH. Okay. Now students, see what is going to be happen in the second step. Step second is that RDS step, redetermining step. So what is going to be happen here? HCO negative, OH and H plus second molecules, because we have taken the two molecules, same molecules we have taken here, one and one same. So here we take another molecules HC double bond OH. Okay. So students, in the presence of second molecules of formaldehyde, the hydrogen will transfer to the here as a hydride negative. Hydride means H negative. It is an unusual way, students. Why it is called unusual way? Because H negative is not a good leaving group. Despite when we leave the position instead of going into the reversible direction. Because OH, since this step is reversible. So your question is, sir, why OH will not undergo into the reversible direction? Students, you know that OH is a good nucleophile, not a good leaving group. So instead of OH and H is the poor leaving group, means that the poor leaving group is the very poor is the OH. So H will leave the positions. Okay. So H will leave the positions. It means what? H will transfer. H will hydride. H will transfer as a second molecules, because the second molecules is a strong acid. A strong acid. So what I am telling you, since H negative is not left the reaction center, rather than the left the reaction center, transfer to the second molecules of aldehyde, because second molecules of aldehyde contains the strong acid. That is the Lewis acid group. Okay. Now see, in this step, hydride transfer is the RDS step. What I'm telling you, the R, that is a hydride transfer is RDS step. Okay. So HCOH, it is the O negative. H is the transfer, means H, when that H will transfer here, what is going to be happen? That see that when the H will transfer here, I write here, when H will, first molecules I write here, when the H will transfer here, the O will like that will move here. Okay. And in that case, HC double bond O, OH will form, that is the acid. Along with that, you will get here, since the H will shift here, that bond will break, and HO negative, H and H, you will get that methoxide ions. Okay. That you will get the methoxide ions, and here is the acetic formic acid. Now in this step, the proton is going to be exchanged here. Proton transfer is here because it is a strong acid. So that will form the HCO O negative plus CH3OH will form. Okay. Students, now you have taken since the NaOH, so Na is still left there. So Na will react with this compound and form the HCOONA. So ultimately, what you understood through this mechanism, students? Did you observe one thing? In the RDS step, there is a how many molecules involved? C here. Students, see. In the RDS step, one these molecules is there. Second, already you have, there is a one nucleophile is there, one more molecules here. Means chemical kinetics tells about this Cannizzaro reaction, that this reactions is the rate is directly proportional to formaldehyde. And how many formaldehyde you have taken? 2 moles and 1 moles of nucleophile. So there is 2 and 1. Total order is 3. Okay. So order of reaction is 3, and overall rate is RDS. Okay. And in the RDS, these things will happen. The 2 moles of aldehyde and 1 moles of OH reacted. All the things comes at the RDS state, and the reaction is these things will happen. Okay. Now, now the point is, through the mechanism, one more thing you can understand here. Students, now see here, we have this compound like formaldehyde, benzaldehyde here, and along with the OH group attached here. the para positions. So what do you think? One more compound I write here. Now you can understand. Nucleophilic addition reactions when happen increases, when nucleophilic addition increases, when electron withdrawing group is there. So in this compound, that group will donate electron to this compound because here is minus M effect. Okay. So in this case, the electron density increases on this carbon and their nucleophilicity decreases, means nucleophilic additions decreases. Therefore, hydrogen cannot leave these positions. Okay. In this, they are just opposite. Here is NO2 group, means the no reverse direction will happen. So their nucleophilic addition reaction will increases. Okay. So electron withdrawing group, when the electron withdrawing group happen, Cannizzaro reaction will be faster. Okay. See that one example I gave here. Here is that benzaldehyde NO2. Here is the benzene CHO, and here is that CHO CH3, and one more example I take here CHO and OCH. Can you tell me the order of which will involve the Cannizzaro reaction faster? This is the first, second, third, and fourth. What will be the order? The first, second, third, and then fourth. This is the order of Cannizzaro reaction. So I hope you understood why this type of reaction not involved in the Cannizzaro reactions. Okay. One more example I give you. C CH3 CCH3 CH3 C double bond O C CH3 CH3 CH3. It also not involved in the Cannizzaro reaction. Why? Still, there is no hydrogens here as a hydride shift. So, you know, in the mechanism we have done that in the hydrogen shift from the one molecules. So suppose the OH minus attack here, then what will happen? The compound will form like that CH3C, CH3, CH3 and CO negative. OH is there, and then CH3, CH3 and CH3 will form. Where is the second hydrogen? Where is the hydrides? How hydrogen will shift to the other molecules of carbonyl groups? So there is no hydride is there, no hydride available there. Correct? Huh? Since there is no hydride available, so it will not also involve the Cannizzaro reaction. Now, one more example I have given here. You can see here, this compound contains no alpha hydrogen, despite being will not involve in the Cannizzaro reaction. Why? Because when the OH minus will attack on this group, then what things will happen? There is Cl, Cl, C, O negative, H and OH will form here. Students, once this electron will shift to this compound, their stability will be increases. You can see because electron withdrawing group is highly stable. So how it will undergoes into the Cannizzaro reaction like that? Okay. So I hope you understood, students. You can judge because two type of compound you will face. One compound you will face which not alpha hydrogens. Second, you will face the which also not contains alpha hydrogens. But how you can determine whether that reaction will undergo into the Cannizzaro reaction or not? Once you understand the mechanism, then you can easily crack that whether which compound will involve the Cannizzaro reaction or not. Okay. Now see here, the one questions came in the 2009 here. Okay, that is JE questions, and already I taught you, so it is very easy for you to give the answer. That is 2 moles of PHCHO group, and here is the OH minus I have taken, and the compound is from PHCH2OH along with that PHCOO negative. Now my questions to you, that is the slowest step you have to find. That first is the transfer of hydride, transfer of a hydride to the what? Carbonyl group. Second is the abstract proton, the abstract of proton from the carboxylic A groups. And third here, the deprotonation of CH2 CHOH. Okay, and fourth option is, and here is that fourth is what is the attack of OH minus at the carboxyl groups. So what do you think, which option is going to be the correct here? See, this is the first, the transfer of hydride ions to the carboxyl group, carbonyl group. This is the correct answer, students, because I have mentioned in the mechanism, the hydride transfer is the slowest state. Okay, I hope you understood the whole logic, whole concept. Okay, thank you so much. Have a nice day.